In this video, we're going to be talking about the differentiation of trig functions, and here's a list of all the derivatives of the trig functions that you should definitely memorize because you can't do the problems without memorizing the functions. Once you know the derivatives of each trig function, the problems become dramatically easier. So in this video, we're going to prove the derivative of sine of x is equal to cosine of x, but that's the only one we're going to prove because tangent x, secant x, cosecant x, and cotangent x are very simple to prove just by using the quotient rule. And you should definitely look up the proof for the cosine of x is equal to the negative sine of x, just in case you're ever in a situation where you don't remember the derivative of cosine of x and you can prove it yourself. Before we prove that the derivative of sine of x is equal to cosine of x, we first have to prove that the limit as theta approaches 0 of sine of theta over theta is equal to 1. So first we need to draw a quarter circle with radius 1 and a center of O on a coordinate plane. Next we will draw a triangle with points A and B where angle AOB is equal to theta. Now we are going to say that theta is greater than 0 for the purposes of this proof. Because of basic trigonometry, we know that the coordinates of B are cosine theta, sine theta. And to find the area of a triangle, you must use the equation area equals 1/2 base times height. In this case, our base is 1 because it is the radius of our circle, and the height is sine of theta. So the area of triangle AOB is half sine of theta. And from geometry, we know that the area of a sector is theta over 2. Now we need to form a larger triangle using the points A, O, and C, AC being a tangent line to the circle. Because the radius of the circle is 1, that means that the length of AC is tangent theta, so the area of triangle AOC is 1/2 tangent theta. Using the intermediate value theorem, we have sine of theta is less than theta over 2, which is less than half tangent theta. Multiplying each portion by 2 and expanding the tangent theta, we are left with sine of theta is less than theta, which is less than sine of theta over cosine of theta. Dividing by sine theta and flipping the signs as well as reciprocating the fractions, we now have the equation 1 is greater than sine of theta over theta, which is greater than the cosine of theta. The limit of cosine of theta as theta approaches 0 is 1. We can now use the squeeze theorem to get that the limit of theta approaching 0 from the positive side of sine of theta over theta equals 1. We also get the same answer as the limit of theta approaches 0 from the left side. Therefore, by limit theorem C, we get that the limit of sine of theta over theta as theta approaches 0 is equal to 1. So we have the function f of x equals sine of x, and we are trying to prove that the derivative of sine of x is equal to cosine of x. In proving this, we will use the limit definition, which is the limit as h approaches 0 of f of x plus h minus f of x all over h. First, we will plug in our function sine of x to get sine of x plus h minus sine x all over h. For this, we need to remember the sum product identity for sine of x minus sine of y. In this case, we are using the letters k and r. K is equal to x plus h and r is equal to x. This formula is 2 times sine of k minus r over 2 times cosine of k plus r over 2. Having this formula, we recognize that the numerator in our limit definition can use this formula. So we then take the 2 outside and multiply it by our new fraction, sine of x plus h minus x over 2, times the cosine of x plus h plus x over 2 all over h. Simplifying the numerator leaves us with this new equation, 2 times sine of h over 2 times this cosine of 2x plus h over 2 all over h. We will now need to separate the sine and cosine of the numerator to be able to recognize another way to simplify. So we now have the equation 2 times sine of h over 2 all over h times the cosine of 2x plus h over 2. We now recognize that this first part of the equation, 2 sine of h over h, is similar to the proof we just did that says the sine of theta over theta is 1 as theta approaches 0. In order to get it more exact and be able to change this equation into a 1, we must multiply the bottom by 2 and divide the h by 2 in order to get 2 times h over 2, which is ultimately the same as h, but allows us to cancel this part of the equation out. Canceling the 2's leaves us with sine of h over 2 times the cosine of 2x plus h over 2. We can now simplify the first part of the equation into a 1, multiplying 1 by cosine of x plus h over 2 after simplifying the 2x plus h over 2. Plugging in 0 for h leaves us with cosine of x plus 0, which gives us the solution to the proof that the derivative of sine of x is equal to the cosine of x. Here's some equations that are really good to know as you're doing the problems to be able to simplify. And these are just really simple. There's two double angle formulas, sine of 2x and then cosine of 2x. And then also the really simple one, sine squared x plus cosine squared x equals 1. These will really help you to be able to simplify what you need to do, especially in the first part of the problem, the worksheet where you don't use the chain rule. So I really wanted to do a problem from the worksheet to show that the equations I gave you that are good to know are really useful in these problems. So we're going to do number 2, which is the function of cosine of x over 1 plus sine x, and we're finding the derivative of this using the quotient rule, which is low d high minus high d low over low squared. So to start off, we're going to multiply the bottom 1 plus sine x times the derivative of the top, which is negative sine x, minus cosine of x times the derivative of the bottom, which is cosine of x as well, over 1 plus sine x squared. Simplifying this, we get negative sine of x minus sine squared x minus cosine squared x over 1 plus sine x squared. And we can now see that we can simplify this even further to negative sine of x minus 1 times sine squared x plus cosine squared x in parentheses over 1 plus sine x squared. We can cross off the sine squared x plus cosine squared x and replace it with the 1. So we're left with negative sine x minus 1 over 1 plus sine x squared. We can take out another negative 1, which leaves us with negative 1 times 1 plus sine x over 1 plus sine x squared. We can cross off the 1 plus sine x and cross off the squared on the bottom, so we're left with negative 1 over 1 plus sine x, which is the derivative to our function cosine of x over 1 plus sine x.